Now we will take the case of stationary waves. I have already told you what are stationary waves. The waves moving with same velocity, same amplitude and same wavelength in the opposite direction, superimposed on each other, they give rise to the so-called stationary waves. Today we will take the example of stationary waves in a pipe open at both ends. Open at both ends. So means the waves will be produced in a pipe which is open at both ends, like this type of waves will be formed in this way. So we will take the case of a pipe which is open at both ends. Now we will find the equation. As we know that the equation of wave moving from left to right is r sine 2 pi upon lambda Vt minus x. Now origin has been shifted to O dash. So the equation of wave will be r sine 2 pi upon lambda into Vt plus x. The wave is moving in from left to right and the origin has been shifted to O dash, and L is the length of this pipe. After reflection, this is very important, after reflection, now it is clear that now the wave will be reflected from the open end. So there will be no any phase reversal. In the previous two examples, we have seen that there was a phase reflection, phase reversal of angle pi, but in this case the wave is reflecting from a open end, so there will be no any phase reflection. So the after reflection y dash double dash will be equal to r sine 2 pi upon lambda Vt minus x. But there will be no any negative sign here because there is no any phase reflection. There is phi is equal to 0. No any phase reflection. So this is the equation of wave moving from right to left after reflection. So according to principle of superposition, we will find that y is equal to y dash plus y double dash, means r sine 2 pi upon lambda Vt plus x, and here plus r sine 2 pi upon lambda Vt minus x. Okay, so here we will apply formula sin c plus sin d, which is equal to 2 sin c plus d upon 2 into cos c minus d upon 2. Unlike the cases which we have studied earlier, now we will apply and we will find that y will be equal to 2 into r sine 2 pi upon lambda, and here it will be Vt, because when they are added we will get only Vt, and cos 2 pi upon lambda into x. So this is the equation for the final wave. And now we will take the amplitude, and it will be A into sine 2 pi upon lambda into Vt, and A amplitude will be equal to 2r cos 2 pi upon lambda into x. Now we will find the conditions. So it is clear that at x is equal to 0 or L. Now it is clear from the diagram, as there is no any closed end, so here the amplitude will be maximum. Amplitude will be equal to maximum, that is plus minus 1. So at x is equal to L, the amplitude will be maximum, that is 2r cos 2 pi upon lambda, and we will put here L in place of x, and you will see that it will be equal to plus minus 1, and the angle 2 pi upon lambda will be equal to, as we know that the cos is 1 at 0 degree, pi, 2 pi means here we can write pi, 2 pi into so on up to n pi. So generally we can write here 2 pi upon lambda into L will be equal to, it will be equal to n pi. So we are left with the value of L will be equal to n lambda upon 2. So this is the condition for the waves, stationary waves in a pipe open at both ends. Now L is equal to n lambda upon 2. This is the condition. Now we will study the various modes of vibration for a first mode of vibration, that is at n is equal to 1. So we will find that n is equal to lambda by 2. This is the condition for first mode of vibration, and it is clear that we will get half wavelength. Means at now, as we know that this is the complete wave. So half wave, but the half wave will be produced in a pipe open at both ends. Means we will be having the wave up to this, okay, half. So in this way, this is the incident wave, and after reflection it will be moving like this, okay. So this is the first mode of vibration, and you are finding here that the node is 1 and antinodes are 2. Nodes is equal to 1 and antinodes are the region at which the displacement is maximum. So node is 1 and antinode is 2. So we will put the frequency V is equal to lambda into nu 1. So in case of lambda, it will be V upon nu 1. Put in this equation the value of lambda. So L will be equal to V upon 2 into nu 1, and this implies that the first harmonic frequency is V upon 2L. So this is the fundamental frequency or first harmonic. Nu 1 is the fundamental frequency. Okay. Now we will study the case of a second mode of vibration. Second mode of vibration, that is n is equal to 2. When we put the value of n is equal to 2, then we will find here L is equal to lambda, only lambda, because 2 and 2 cancel हो जाएंगे, and we will find L is equal to lambda. So now means complete wave in this way, but you will find that we cannot represent the wave like this because the boundaries are open, means from this, and after that complete wave के लिए it will be in this way, means this will be the complete wave in this way from this point to this point, and we will be able to write here this is the in this way, this is the complete wave, okay. So means this is incident, and after reflection from the free end you will find this like this. So this is the reflected wave and this is the incident wave. So means you will find here 1, 2 nodes, number of nodes is equal to 2, and antinodes 1, 2 and 3, and antinodes are 3. This is the condition. Now we will find the value of a nu 2, means V is equal to lambda into nu 2. This implies that nu 2 is equal to, or we will put the value of lambda, it will be equal to V upon nu 2. Put in this equation. So L is equal to L is equal to V upon nu 2. This implies that nu 2 is equal to V upon L. So you will find that nu 2 is equal to 2 into nu 1. So this is the second mode of vibration. For third mode of vibration, third mode, we will put the value of n is equal to 3. So in this equation, this is the, so we will find that L is equal to 3 lambda upon 2. We are putting the values in this equation, which is the base equation, as equal to n lambda upon 2. So here it is clear that we will have 1 and a half, 1 plus half wave. So you will find that how will we represent it in this way. This is the, basically this is 1 and half wave, but it will be the case when the pipe is closed at both ends. But now in this way we will be having like this 1 and half wave. So open end from this to this. In this way you will be able to draw the diagram. Means in the pipe of length L, we will have this type of equation in this way, and after that in this way. This is the condition, and after reflection the wave will be produced like this. Means 1, 2, 3, 4 number of antinodes is equal to 1, 2, 3, 4, and nodes are equal to 1, 2, 3. So antinodes will be equal to 3. So now the value of nu 3 means V is equal to lambda into nu 3. So we will put the value of lambda means V upon, so L will be equal to, from here lambda is equal to V upon nu 3. So put this equation in this, L will be equal to 3 into V upon 2 into nu 3. So it is clear that, or we can write nu 3 is equal to L is equal to this, and nu 3 will be equal to 3 upon 2 into V upon L. So it is clear that nu 3 will be equal to 3 into nu 1. So if we find the ratio of nu 1, nu 2 is to nu 3, means nu 1 is to nu 2 is to nu 3 will be equal to 1 is to 2 is to 3. So this is the case for the waves produced in a pipe closed at, open at both ends. Okay, thank you.